What's actually at the bottom of a black hole? Part 1. The mystery. Every black hole in the universe is hiding something, not just darkness, an answer. One that might break physics itself. We've taken pictures of black holes now. We know they're real. We know they bend light, swallow stars, and warp time itself. But here's the part almost nobody talks about. We don't actually know what's inside one because nothing that goes in ever comes back out to tell us. The edge of a black hole is called the event horizon, basically the point of no return. Past this line, the escape speed, the speed you'd need to break free, is faster than light. Since nothing travels faster than light, nothing ever leaves once it crosses over. Part 2. Falling in from the outside, if you watch someone fall toward a black hole, you'd never actually see them cross that line. Time slows down so much near the horizon that they'd appear to freeze, fading slowly into darkness forever. From their own perspective, though, they'd cross it just fine and keep falling. For a few seconds, nothing would feel different. Then gravity would pull harder on their feet than their head. That difference would stretch them, a process scientists call spaghettification, which just means being stretched out long and thin like a noodle. By the time they reached the center, they wouldn't be a person anymore, just a thin stream of particles falling towards something we still can't explain. At the center, everything that ever fell in gets crushed into a single point, infinitely small, infinitely dense. This is called the singularity, basically a single point packed with so much matter it has no size at all. Part 3. Physics breaks. Here's the problem. At that point, our equations stop working. Einstein's theory of relativity, the set of rules that explains how gravity works, explains almost everything perfectly everywhere else. But it completely breaks down here. It predicts infinite density and infinite curvature, numbers that don't make physical sense. Most physicists don't think the singularity is actually infinite in reality. They think general relativity is incomplete, that we're missing a piece of physics that only shows up at the smallest scales. In the 1970s, physicist Stephen Hawking discovered something that should have been impossible. Black holes aren't truly eternal. They slowly leak energy and evaporate. It happens because of quantum effects, strange behavior that happens at the tiniest scales, smaller than atoms, right at the edge of the event horizon, where pairs of particles can briefly appear, one falling in while the other escapes. This slow leak is now called Hawking radiation, basically energy slowly escaping a black hole over time. Over unimaginable timescales, that leak adds up. Eventually, the black hole shrinks completely away. Part 4. The paradox. But that raises a disturbing question. If a black hole eventually disappears completely, what happens to everything and everyone that ever fell in? Physics has a rule. Information can never truly be destroyed. So if a black hole vanishes, where did all that information go? This is called the black hole information paradox, a problem that seems to break the rules and still has no clear answer. For decades, it had no good solution. Some physicists think the information gets scrambled and slowly released in the radiation. Others think black holes might connect to white holes, theoretical objects that spit matter out instead of pulling it in. One of the strangest proposed solutions goes even further. It's called the Holographic Principle, an idea that everything could be stored like a 3D image encoded onto a flat surface. It suggests everything that falls in gets encoded, like a hologram, onto the surface of the event horizon itself. Not lost, just stored differently, smeared across the boundary. If true, a black hole isn't really a hole at all, but more like a cosmic hard drive that nothing ever truly leaves. Common myths about black holes. Myth 1. Black holes are giant cosmic vacuums sucking in everything nearby. Not true. If our sun became a black hole today, Earth would keep orbiting exactly the same way. Its gravity wouldn't get stronger. You'd only fall in if you got way too close. Myth 2. Black holes are massive in size. Many stellar black holes could fit their core into something smaller than a city block. Myth 3. Getting near one rips you apart instantly. Actually, the bigger the black hole, the gentler the pull near the event horizon, meaning the stretching force is much weaker. You could cross into a supermassive black hole without even noticing. Myth 4. Every black hole used to be a giant star. Some scientists think tiny primordial black holes, ones that may have formed shortly after the Big Bang, could also exist. If they do, they would have formed in a completely different way than stellar black holes.